we are going to look at lesson 6.4 from Math 2, which is all about trig. So trig is a type of math that is specifically assigned to right triangles. And there's going to be three types of trig that we're going to look at. And those ratios are going to have to do with the sides of the triangle and how they relate to a specific angle. So when you are going to do trig, first of all, an angle specifically has to be identified. So this one for us has this angle identified right here. It has that Greek letter theta in the middle of it. You'll find that letter to be used quite often in trig. I don't know why all of a sudden we decide to use that, but they do. So we're looking at this particular angle, and then we want to identify the sides of the right triangle in how they relate to that particular angle. So the hypotenuse, we know that's always the longest side. It's the one that doesn't touch the right angle or is opposite the right angle. Sometimes you'll hear it referred to that way. So here we have our hypotenuse. That will never change. The hypotenuse is the hypotenuse, just like it was back when you were doing Pythagorean theorem and all that type of thing. These are the two that will change: opposite and adjacent. So opposite means that it doesn't touch. So here's our angle over here, the side that it does not touch. So see how it touches the hypotenuse and it touches the adjacent? The one it does not touch is the opposite side. The side that it does touch, that's the leg, that's called the adjacent. You may have heard like the apartments have their adjacent wall. It's the one that they share or they both touch. There'd be apartments or hotel rooms that are right next to each other sharing a wall. That's kind of the idea here. It's a side that is shared by the angle and the hypotenuse. So the three trig relationships are represented by these abbreviations, but I'm going to tell you what they are for real so you know how to spell them correctly. This one is sine, and you do not say sin as an abbreviation. It really is sine. If you were to write the whole word out, it just has an E on the end. So the sine of theta is opposite over hypotenuse, and these are lengths. So you would write the length of this opposite side over the length of the hypotenuse. Remember, the hypotenuse is always the longest side of a triangle, so you should have a smaller number over a bigger number. And then our next one is cosine, and you don't just say cos, it's cosine, even if you just see the abbreviation. So the cosine of theta is the adjacent length over the hypotenuse length. So you would take the length written here and take that as your top number, and the hypotenuse length here would be your denominator. Remember, your hypotenuse is always the longest side, so it will be smaller over bigger. And then the last type of trig statement for the right triangle is tangent. There it is all written out. The tangent of theta would be opposite over adjacent. So this length of the opposite over this length of the adjacent. Now, you don't know which one of those is necessarily going to be longer, so there's not like small over big or anything like that. It's just opposite length over adjacent length. This is the only one that could end up with a value of more than 1, because on the others, remember, you're dividing by the bigger number, so those are all going to end up as less than 1. But tangent could be less than 1, or it could be bigger than 1. So there's an abbreviation that every time you hear people talking about trigonometry, they're going to say. It's SOHCAHTOA. SOHCAHTOA. And those letters are very specific. They're saying sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So when you read SOHCAHTOA or say SOHCAHTOA, you're thinking about the trig statement first, then the top, and then the bottom of your fraction. Trig, top, bottom, trig, top, bottom. So every time you're thinking that through, you're thinking through your trig statement. All right, so we're going to do the sine, cosine, and tangent of letter A first. So you'll notice every time you see sine, cosine, and tangent, they have to have an angle identified. So in this case, it's going to be angle A. So I like to go to my diagram, find that angle, and color it in. It's just a little easier to realize which angle it is we're talking about. Now the hypotenuse is always the longest side, the one that does not touch the right angle. So I know this is the hypotenuse. The side that touches the angle we're talking about, or angle A, that would be this one. So this is the adjacent. And the one that does not touch it will be our opposite. So I just use those 3-letter abbreviations. Some people just use 1 letter, whatever you want. Doesn't matter to me. So the sine is opposite over hypotenuse. So opposite would be A, and the hypotenuse is C. Now remember, these are going to be numbers as we're working along. Cosine of A, so cosine is adjacent over hypotenuse. So adjacent, which would be B, over the hypotenuse of C. And then the tangent, that's our TOA. Tangent is opposite over adjacent. So our opposite length is A, and our adjacent length is B. Now right next to it, it asks us to do the sine, cosine, and tangent of B. So as I go back over here, I'm going to need to erase a little bit of what I have. There's one thing that's going to stay. That one thing that's going to stay is the hypotenuse, because that will never change. It doesn't matter which angle we're looking at, the hypotenuse is still the hypotenuse. So these second set of questions ask us to focus on the sine of B, cosine of B, tangent of B. So B is the angle that we're going to focus on. So the hypotenuse is still over here. The one that touches angle B, the adjacent, is now here, and opposite angle B would be over here. So now we're going to do sine, cosine, and tangent. So sine is opposite over hypotenuse, so B over C. The cosine is adjacent over hypotenuse, so adjacent over hypotenuse, A over C. And the tangent, opposite over adjacent, so opposite over adjacent, so we get B over A. Now I wanted to do it this way because I wanted you to just see something real quickly. When you are talking about opposite angles within the same triangle, the sine and cosine of opposite angles will be the same. The sine and cosine of opposite angles will be the same, and then what you should notice about your tangents is they are reciprocals of one another. Alright, now this asks us to find the sine, cosine, and tangent of angle S and write each answer as a fraction. So the sine, cosine, and tangent of angle S. So we need to have that identification there saying which angle is our angle of focus. I'm going to color in angle S. We need to identify the sides. So 13 is our hypotenuse. The side that touches angle S is the one with the 12 on it. That would be our adjacent. And the one that doesn't touch it, the 5, is our opposite. So sine is opposite over hypotenuse, so 5 over 13. Cosine is adjacent over hypotenuse, so 12 over 13. And tangent is opposite over adjacent, so 5 over 12. Now keep in mind that we would always simplify fractions if you are able to do so. That's never something you should have to question. We always simplify fractions. As we look at another example, for some reason this cut the directions off of the top when I printed it. I don't know why, but it did ask us to find the sine, cosine, and tangent of letter C. So again, we're going to go through those same steps. We want to highlight angle C, and then we're going to find the sides. So 17, the longest side across from that 90-degree angle, is the hypotenuse. Touching angle C is our adjacent, that'll be 15. And the one that does not touch angle C, where the 8 is over here, that will be our opposite. Sine is opposite over hypotenuse, so 8 over 17. Cosine is adjacent over hypotenuse, so 15 over 17. And tangent is opposite over adjacent, so 8 over 15. And we would simplify those if we could. Next we have sine, cosine, and tangent in this drawing of angle A. So angle A will be our angle of focus in just a second. As soon as I write this down, we'll color in angle A and identify our sides. So the hypotenuse, the one across from the 90-degree angle. The one that touches angle C is our 40, that would be our adjacent. And the one that doesn't touch it, the 30 over here, will be our opposite. Sine is opposite over hypotenuse, so 30 over 50. Oh, that simplifies. Those both simplify by 10, so we get 3/5. And then cosine is adjacent over hypotenuse, so 40 over 50, and that simplifies by tens, so 4/5. And tangent opposite over adjacent, so 30 over 40, and that simplifies by tens, and we have 3/4. You're going to see 3s and 4s and 5s in a lot of these because right triangles are often Pythagorean triples. The next portion asks us to use our calculator to find the value of each to the nearest 10,000th. So first of all, let's remind ourselves of what that means. So here's the ones place. After that would be tenths, hundredths, thousandths, 10,000ths. So we need 4 numbers after the decimal place. So our calculator will do sine, cosine, and tangent for us. You don't have to have a graphing calculator, although you most certainly could. But on just even one of these TI-30s, you will see sine, cosine, and tangent. However, you do need to know that your calculator has to be in the right mode setting. So there are settings for degrees and radians. Those are the 2 different ways that you can measure angles. So right now you don't really know much about that, but just trust me that later on you're going to measure some things in radians. So you do want to make sure that you are in degrees. So for some of you, you'll have to go into your mode. It's just really a matter of which type of calculator that you're using. But once you have it set in the right mode, then you just take sine, cosine, or tangent. You hit whichever button you're supposed to be finding. So in this case, we're finding the sine of 21 degrees. So I'm just going to put in sine 21, hit enter, and as you can see, my calculator screen fills up with a bunch of stuff. I just need the first 4 numbers after the decimal, so 3583. But that requires me to check the 5th number. If it's 5 or bigger, the one in front of it has to go up 1. So that's 6 is going to bump this up to a 4. So 0.3584. And remember, sine and cosine should always be less than 1. Tangent's the only one that's allowed to be anything bigger than that. So then I'm just going to be typing these in and writing out the appropriate response. So the sine of 85, hit enter, and again I only want 4 numbers after the decimal, so 9961, but the number after the 1 is 5 or bigger, so it's going to bump it up to a 2, so 0.9962. And trying to make sure you can see in the reflections there. The tangent of 67, so you'll notice here we've got a number in front of the decimal, and that's okay. The only thing that can't have the number in front of the decimal, sine and cosine, tangent can be any type of value, so 2.355, and then I want to put an 8, but the number after it is 5 or bigger, so that 8 needs to become a 9. Cosine 45, 0.707. Then we've got a 1, and the number after it is not 5 or bigger, so it's going to remain a 1. It's okay if your angle even happens to be a decimal in and of itself. It still works out okay. So we're going to be doing the cosine of 50.5, and we get 0.636. Then I want to put a 0, but the number after it is 5 or bigger, so that 0 has to bump up to a 1. And last but not least, the tangent of 30, and we get 0.577, a 3, but the number after it is 5 or bigger, so that 3 is going to go up to a 4. Then I want to also show you that you can actually work backwards. So if you have a trig ratio and you're trying to find the angle measure, as long as you know the value of that trig ratio, that would allow you to find the angle measure. So let me just do a little diagram down here. Let's say this was my angle that I'm trying to find, and I know that this length is 10 and the hypotenuse is 20. Well, as I look at that, this hypotenuse is the length of 20. The 10 is an angle that, or the side that doesn't touch this angle. This would be the adjacent down here. I don't have any number written there. This one over here would be the opposite. So the trig that uses opposite and hypotenuse is sine. So I would say, hey, the sine of what I'm looking for is opposite over hypotenuse, so 10 over 20, which simplifies. We always simplify. So what we're looking for, the sine of something, is a half. So we can actually find out what that something is by using these up here that are called inverse operators. So it takes our work and goes backwards. And those are also on your calculator. Same sine, cosine, tangent buttons. See if I can get it to focus there. Above it, in whatever your alternate color is, mine's yellow, it says sine -1, cosine -1, tangent -1. I know for some reason it's not focusing on those. But to get to that, we would use our second function. So second, mine's yellow, and then sine. So I'll get sine -1 in my calculator screen. Hopefully you can see that. Now I want to put in 1/2. So 1 divided by 2, and hit enter, and I get 30. So that's telling me, hey, this angle measure right here that I wanted to know, that's 30 degrees. So if we're doing an inverse, we're finding the degree of an angle. And this asks us to do the nearest tenth, so remember it's tenths, hundredths, so just one number after the decimal. So this is the one we just did. So here x would be 30 degrees. There was no need for a decimal on that one. And we can do these others as well. So if the sine of x is 9/10, and we were trying to figure out what x is, inverse sine, or second sine, 9/10. Hit enter, and we get 64.15, so 64 point, and then the number after the 1 is 5 or bigger, so we're going to make that a 2. So x is 64.2 degrees. And it doesn't matter whether it's sine, cosine, or tangent, it's still the same steps. So for the sine equaling, or sorry, the tangent equaling 2/5, we'll do second tangent, 2 divided by 5, and we get 21.80, so 21.8. Cosine equals 3/25, so inverse cosine, 3/25. We get 83.10, so that would just be 83.1. And remember, we're finding degrees, so make sure you put your degree symbol on your answer. And let's see, cosine is 3/4, so inverse cosine, 3 divided by 4. And we get 41.40, so 41.4 degrees. And lastly, inverse tangent, 5 divided by 4. And we get x to be 51.34, so 0.3 degrees. And in the future, there'll be some other questions later where you're going to need to find the angle measure, so you'll want to keep that in mind, that you can use your inverse function to help you find the angle measure.